Hey kids, Miss Kulkarni here. In this video, let's continue with Lewis dot structures for covalent compounds, and we will actually go through double, triple bond and also extended octet. But before that, this is to remind you about certain steps to draw Lewis dot structures. Step number 1. We need to take account of valence electrons for every single atom present in that compound or for an ion. When we find out, the next step is you add up and you get the total number of valence electron. Step number 2. This is about selection for the central atom. Usually it is the atom which has the fewest number. But suppose if we have same number of atoms, then we go with the least electronegative atom. Step number 3. Remember always, hydrogen and fluorine can never ever be central atoms. So don't put those as central atoms. And once we have the selection for central atom, we put remaining atoms around that central atom. Step number 4. We form covalent bonds by actually putting a pair of electrons between the central atom and the surrounding atom. Each bond corresponds to 2 electrons. Just keep that in mind. Number 5. In this step, we start filling up with the electrons, and we have to make sure that we follow octet rule. So there must be 8 electrons around atoms that are surrounding the central atom, and then there are some exceptions for octet rule. So hydrogen only likes to have 2 electrons maximum, beryllium only likes to have 4 electrons, and boron is happy with 6 electrons. But sometimes S and P will have more than 8 electrons. That's called expanded octet. Just keep in mind, these could be group 18 elements. And after we place all the electrons, if there is any of the atom which does not complete the octet, then there is more sharing which results into double bond or triple bond. So let's find out more about these unusual Lewis dot structures. Alright, this is our first example, N2. We have 2 atoms of nitrogen. So each atom is going to bring 5 electrons. So total number of electrons are 10. In this molecule, it doesn't really matter which atom is the central atom because we have exactly same atom over there. So we have 2 nitrogen. We begin by putting 2 electrons between the 2 nitrogen. And then out of 10, if 2 electrons are gone, we are left with 8. Let's divide those equally. So we end up having 4 electrons around each nitrogen. What happens with this is, although we are done putting all 10 electrons, this is not a satisfied octet. So to make sure the octet is satisfied, nitrogen decides to share these 2 pairs of electrons. And then what do we get? We end up having this structure, which means we have 3 shared pair of electrons. So if I want to write down that structure as bond, we can write 3 bonds and these 2 electrons over here. Let's find out the ABX formula for this compound. A stands for the number of central atom. Since both atoms are same, we can consider either one as a central atom. So second nitrogen becomes the peripheral atom. And of course there are no electrons which are unshared. So that's it. The ABX formula is AB. Let's move on to the next example. In this example, we have 2 negative as the charge on that polyatomic ion. And we have CO3, which is carbonate. So let's take the count. 1 carbon. Carbon comes from group 16. So we have 4 valence electron for each carbon. That makes a total of 4. We have 3 oxygen, and that comes from group 16. So we have 3 times 6, 18 as the electrons from oxygen. When we add these two, we are getting 22 electrons. But keep in mind, we are -2 charge, which indicates that 2 electrons gain. So we add those 2 electrons and that becomes 24. So we have 24 valence electron. Now, which one comes in the middle? We are going to use the least atom, which is carbon, and then remaining atoms we are going to surround. Next step is we put electrons between each of the central atom and peripheral atom, and then we are going to satisfy each of the elements octet. So let's do that. And when we do that, we realize, so we have used 8 times 3, 24 electrons already. Look carefully. Carbon, which we have here, has only 6 electrons. Carbon is not happy. So what does oxygen say? Oxygen says, okay, why don't you share? So when that happens, this is what we get, because we have 2 shared pair of electrons now. And then how do we write ABX formula? A is the number of central atom, which is 1. B is number of peripheral atoms, and we have 3. And there's no X. So that's it. AB3. So let's work on some more practice now. And we will begin our process by finding number of valence electron. So for CO2, we got 1 carbon and 2 oxygen. For C2H4, we got 2 carbon and 4 hydrogen atoms. Let's go back to CO2. The element in the middle or central atom will be carbon, and we are going to have both this oxygen on the other side of carbon. We begin with shaking hands, and then we start completing the octet till we run out of the electrons. So if we do this, both oxygen are happy with 8 electrons, but carbon is only having 2 and 2, 4 electrons. So what happens? Oxygen decides to share the electrons with carbon. So when that sharing takes place, this is what we get. So for each of the oxygen, we have 8 electrons. And also for each of the carbon, we have 8 electrons. Let's work on C2H4. And in this compound, we have both the atoms, carbon as central atom, and we have hydrogen surrounding those central atoms. Now the very first thing is you're going to put 2 electrons between carbon, and then start putting electrons such a way that the element around that central atom is happy. Well, we have all hydrogen atoms, and each one can only take 2 electrons. So we did that, and then we take the count. So we have 6 here, 7, 8, and 9, 10. We are still left with 2 electrons. So let's go ahead and put those in between the carbon. And now at this point, we have octet complete, and we also have octet complete over here. So in a way, this is carbon with double bond, and then we have 2 hydrogen atoms. What about the ABX formula for both of those? A is the atoms in the middle. We only have 1 carbon, so let's put A. B is the atom surrounding, and we have 2, so we put AB2. And there are no spare electrons, so there is no X. How about the last one? Over here, we have 2 carbon atoms at the central, so let's put that 2. How many atoms are surrounding that? And we got 4, so it's A2B4. How about electron pair which is loose, unshared? We don't have it, so that's it. The formula is A2B4. Now remember, we talked about octet rule, which means every element needs 8 electrons to satisfy them. But sometimes octet rule could be different. We may have an expanded octet. What it means is you may have more than 8 electrons around that atom. Now what I did here is for each of the compound, I took the count for electrons. So we are ready to work on Lewis dot structure. So BrF5. Central atom obviously is Br, and we have 5 fluorine atoms that are surrounding that bromide. Then we need to make sure that we are actually having a bond between these two phases. So every element got 2 electrons shared with bromine. Next step is bromine is going to make sure everybody around it is going to be happy, and that's possible if every single atom gains extra electrons, and those should be total 8 electrons. Now before we move on, let's take the count. Around every atom we have 8 electrons, so we have 5 atoms. That means 8 times 5, which is 40. We have 42 electrons. So you can actually show the remaining 2 electrons on the body of BrF5. So what happens to the ABX formula? A is the element number which is in the middle. We only have 1, so it's A. Elements around fluorine, we have 5. And then there is X. And we have 1 pair of electrons that is not shared. So X is equal to 1. In this example over here, we have 28 electrons as valence electron. So let's look at our figure now. We got chlorine as our central atom. We put all fluorines around that. We completed the octet for each of the fluorine. And then we find out how many are utilized. So around each fluorine I have 8. That means 8 times 3, 24 electrons are shown in the figure. Out of 28, 24 electrons are used up. That means we have still 4 electrons remaining, and they are going to be on the chlorine atom. So look at this. We got 2 electron pairs for chlorine. And what will be the ABX formula? We have A, which is central atom. That's only 1. We have B's surrounding atoms. Those are 3. And then we have to think about X. And we have 2 pairs of electrons. Let's do one more example. In this example, we have sulfur as central atom. And obviously, we are going to get all fluorine atoms around sulfur. So the very first thing is going to put 2 atoms in between the element and the central atom. Next step is we have to make sure that octets are complete for every single element. The next step you do is take the count of electrons, and we have 8 electrons around every single fluorine. That means the number of electrons is 4 times 8, which is 32. Out of 34, we use 32. That means there are 2 electrons remaining. We can just put the 2 arrows, and don't forget to put a circle around that. Now one final thing, let's write ABX formula for this. A is going to be 1 because we have only 1 central atom. B is the surrounding atom or bonds, which will be 4. And X is actually extra pair of electrons which are there on the central atom. So we have AB4X. So I hope you guys enjoyed the video. I will see you again in next video. Until then, bye bye.